What was the deepest ocean trench descent like? Imagine descending into a world where sunlight never reaches and pressure is over 1,000 times what we experience at sea level. That's what it's like to explore the deepest part of the ocean. The Mariana Trench, located in the western Pacific Ocean, is the deepest ocean trench on Earth. Its lowest point, called the Challenger Deep, reaches about 10,900 to 11,000 meters deep. That's roughly 36,000 feet below the surface. Reaching this depth is one of the most impressive achievements in human exploration. It shows how far technology and human courage can go in extreme environments. The first successful manned trip to the Challenger Deep happened in January 1960. Jack Pickard, a Swiss oceanographer, and Don Walsh, a United States Navy lieutenant, rowed in a specially built submersible called the Trieste. They went down to a depth of about 10,916 meters. The trip took several hours, and the pressure on the vessel was over 1,000 times the pressure we feel at sea level. Despite the crushing force and total darkness, they saw strange creatures like tiny shrimps and a flatfish that had never been seen before. This showed that life can survive even in the most extreme conditions deep in the ocean. The submersible used for this journey was built to withstand incredible pressure. Its hull was made of thick steel, and it floated on gasoline, which is less compressible than water. This helped it stay buoyant at such depths. Communication with the surface was limited, so the explorers relied on their instruments and the vessel's integrity. Since that historic dive, nearly 30 more expeditions have reached the trench using advanced robots and remotely operated vehicles. These missions have helped scientists learn more about the geology and biology of the trench. The trench forms where the Pacific tectonic plate slides under the Philippine plate, creating a deep, narrow valley on the ocean floor. Exploring this part of the ocean is not just about pushing limits, it's about understanding how our planet works. These missions have expanded our knowledge of the extreme conditions in the deep ocean, the ability of life to adapt, and the processes shaping Earth's crust. They also inspire new designs for submersibles and underwater robots, helping us better monitor and study environments that are almost impossible to reach.